Hello friends, I welcome you in lecture number 35 on hypothesis testing. In lecture number 34, we have introduced chi-square test of independence and we have seen one example on this test in lecture number 34. In this lecture also we will discuss another example on chi-square test of independence. So we just recall that in chi-square test of independence we are considering two variables, say variable 1 and variable 2, and both are categorical variables, and we are interested in testing the null hypothesis that these two variables are independent, and for that we are considering this chi-square test, and test statistic is given by chi-square equal to sigma observed minus expected frequency whole square divided by expected frequencies. And to find out critical values, we consider degrees of freedom equal to number of rows minus 1 times number of columns minus 1. Whenever we have this chi-square test of independence, we will have our question always in this form. We will be given this type of tabular data or this type of contingency table which indicates different categories for variable 1 and variable 2, and here we will have observed frequencies, and we will find out expected frequencies, and then we will find out value of test statistic using this formula. After that we will find out critical value at given level of significance and this number of degrees of freedom, and then we will compare this test statistic value with this critical value and we will take the decision. So here we are going to consider this example. A company has to choose among 3 pension plans. Management wishes to know whether the preference for plans is independent of job classification and wants to use alpha equal to 0.05 level of significance. The opinions of a random sample of 500 employees are shown in following table. Here we have two categories. One category is pension plan, and we have two variables. One variable is pension plan, and there are 3 categories for this variable pension plan. Pension plan number 1, pension plan number 2, and pension plan number 3. And another variable is job classification. So for this variable there are 2 categories. First classification is salaried workers and hourly workers is the second classification. So there are 2 categories for this variable job classification, and for this variable pension plan there are 3 categories. So we have 2 rows and 3 columns. These 2 we will consider as 2 rows, and this 3 pension plan will give us 3 columns. So we have 2 by 3 contingency table, and here we can understand in this way. There are 160 workers which are coming into these 2 categories. 160 workers are salaried workers who are interested in pension plan number 1. Similarly, 140 workers are salaried workers and they are interested in pension plan number 2, and similarly other categories. There are 60 workers whose job classification is hourly workers and they are interested in pension plan number 3. So we are interested in the null hypothesis testing that pension plan and job classification are independent. Our null hypothesis will be that pension plan is independent of job classification. So we are going to test that null hypothesis, and all these are totals corresponding to these pension plans. There are 200 workers out of 500 which are interested in pension plan number 1. Similarly, there are 340 workers which are salaried workers out of 500 workers, and these are the observed frequencies. Now, using this sample data, we have to test the null hypothesis that preference for plans is independent of job classification, and alternative hypothesis we can denote by H1 or H suffix A. Preference for plans is not independent of job classification. There are two variables. One variable is preference for plans, another variable is job classification. So we are assuming the null hypothesis that preference for plans is independent of job classification, and this is alternative hypothesis. Level of significance is given as 0.05. Now, to apply this chi-square test, we will require expected frequencies. So expected frequencies are those frequencies which we can obtain by assuming that null hypothesis is true, that is, preference for plans and job classification are independent. For example, suppose we are interested in the expected frequency corresponding to this cell, then here we can see this corresponds to salaried workers and pension plan number 1. So we are interested in the expected frequencies for these two categories. How many salaried workers are interested in pension plan number 1? So we are interested in the number of salaried workers which are interested in pension plan number 1. Now we have assumed that null hypothesis is correct, therefore these two events are independent, that worker is a salaried worker and the worker likes pension plan 1. So if we assume that null hypothesis is correct, then this is probability of intersection of these two events, probability of salaried workers and number of probability that workers like pension plan 1, and we assume that these given two variables are independent, therefore we know that probability of intersection of two events is equal to product of those two events if they are independent. So suppose I am interested in the probability of these two events, intersection of these two events. One event we consider as worker is salaried worker, another event is worker likes pension plan number 1. So because we assume that independence is there, we assume that null hypothesis is correct. That means there is independence between job classification and pension plans. So using that null hypothesis assumption, we can write down probability of this intersection of these two events equal to product of their probabilities. Now what is probability that worker is a salaried worker? So that is equal to we have to find out the number of workers who are salaried workers, and that we can find from this. There are total 500 workers, out of them 340 are salaried workers. So here we write this probability equal to 340 divided by 500. Similarly, we are interested in the probability for pension plan 1. How many workers are interested in pension plan 1? So there are 200 workers which are interested in this pension plan 1 number 1 out of 500 workers. So that is given by 200 divided by 500. So if we find out addition of these two, if we find out product of these two, then we will obtain the probability that we have salaried workers and workers who likes pension plan 1. Probability of the event that worker is a salaried worker and worker likes pension plan 1 is given by this product. Now we are interested in the number of workers who are salaried and they like pension plan 1. So for that we have to multiply this probability by total number of workers. So if we multiply this by total number of workers, which are 500, then we will obtain the number of workers who are salaried workers and who like or who are interested in pension plan 1. So if we multiply this quantity by 500, this 500 will cancel out and we have 340 into 200 divided by 500, and you can see it is nothing but we are interested in the expected frequency corresponding to this. So this is the row total corresponding to salaried workers and this is column total corresponding to pension plan 1, and we have obtained that the expected frequency is 340 into 200 divided by sample size, which is 500. So you can see we have obtained this number here. So that is the reason why we are taking a row total times column total divided by total number of observations. So this is just for understanding that why we are taking row total into column total divided by sample size to write down the expected frequencies. So here the expected frequency corresponding to 160 will be equal to row total corresponding to 160, which is 340, into column total corresponding to 160, which is 200, divided by 500. So let me cancel this and this also, and I have 5 into 4, 20, and this is going to be 136. Therefore the expected frequency corresponding to 160 is 136. Similarly, if I am interested in the expected frequency corresponding to this cell, then this cell is in first row, so I will consider first row total. This cell is in second column, therefore I will take second column total and I will divide by 500, and we can see this is going to cancel out, and let me cancel this 0 here, and I have 5 into 4, so again I will obtain 136 here also. 34 times 4 is 136. Similarly, I can write down the expected frequency corresponding to this cell. It is in first row, so I consider first row total. It is in third column, so I will consider third column total divided by 500, and this will get cancelled, this 0, and I have 5 into 2, 10, 34 into 2 is 68. So similarly we can write down the remaining expected frequencies. So I have prepared the table for observed frequencies and expected frequencies. This is what we calculated right now, and corresponding to 40 expected frequency is 68 here. Suppose I am interested in the expected frequency corresponding to this cell, then this is in second row, so I will take 160 and I will multiply this 160 by 200 and I will divide by 500. So 160 into 200 equal to divided by 500, that turns out to be 64. Similarly, here I have 60 and I am interested in the corresponding expected frequency. This 60 is in second row. I will consider 160 and this 60 is in second column. So I will multiply this 160 and 200 and I will divide by 500 and I will obtain 64. Same thing here for this 60 also. It is in second row. So we will consider 160 multiplied with this third column total, which is 100, and then we divide by 500 and we obtain 32. So these are the expected frequencies corresponding to given observed frequencies, and here we assume that this job classification and pension plan are independent of each other. Using that assumption, we have written these expected frequencies. For example, if I am interested in the probability that this hourly workers or worker is having this job classification, worker is hourly worker and he likes pension plan number 3. So because null hypothesis is correct, this is equal to probability that worker is hourly worker and probability that worker likes pension plan 3. Now what is probability of hourly workers? So total number of hourly workers are 160. So that is divided by 500. So I write 160 divided by 500, and the number of workers who are interested in pension plan 3 is 100 out of 500. So that I multiply by 500. So this is the probability that job classification is hourly workers and pension plan is 3. So this joint probability is equal to 160 into 100 divided by 500 into 500, and if we multiply this probability by 500, we will have 160 into 100 divided by 500. So that is nothing but expected number of workers who are hourly workers as well as who are interested in pension plan number 3. So you can see I have this 32 and this row total is 160 and column total is 100. So I have taken row total into column total divided by total number of observations. So we are using the null hypothesis assumption. We assume that null hypothesis is true and we are testing this assumption. So therefore we are using this assumption to calculate the corresponding expected frequencies. Now once we have all the expected frequencies, then we can find out value of test statistic. So for that we have to take the difference of corresponding observed and expected frequencies, take the square of that difference, divide by that expected frequency. So first term will be 160 minus 136 whole square divided by 136. Second term is 140 minus 136 whole square divided by 136. Third term will be 40 minus 68 whole square divided by 68. So that I have written here. Similarly, next term will be 40 minus 64 whole square divided by 64. Then 60 minus 64 whole square divided by 64 and 60 minus 32 whole square divided by 32. So we are calculating value of test statistic using this formula, and if we find out sum of all these quantities using scientific calculator up to 4 decimal places, we obtain value of test statistic as 49.6323. So this is the value of chi-square test statistic. And here we observe that all the expected frequencies are greater than or equal to 5. Therefore, we are able to apply this chi-square test statistic. Now, once we obtain value of test statistic, we have to find out the critical value for this chi-square test, and we are familiar with the graph of this chi-square distribution. It is a bell shaped, it is not bell shaped, it is asymmetric curve having a longer tail towards the right side. Here level of significance is 0.05. So if I consider this point as chi-square suffix 0.05, then area to the right of this point is 0.05, and here minimum value is 0. We know that chi-square distribution always takes non-negative values. What about number of degrees of freedom? So it is going to be number of rows minus 1 into number of columns minus 1. Here we have 2 rows and 3 columns. So we have degrees of freedom equal to 2 minus 1 times 3 minus 1, that is 1 into 2, which is 2. So we have to find out chi-square critical value for alpha equal to 0.05 and 2 degrees of freedom. So let's use this chi-square table. Alpha is 0.05 and 2 degrees of freedom. So if we take intersection of these two rows and column, then what is the intersecting point? So this is the intersecting point. Let me remove this, and I have this chi-square critical value at 0.05 level of significance with 2 degrees of freedom is 5.991. Number of degrees of freedom are 2, alpha is 0.05. So this is our critical value, 5.991, and area to the right side of this value is rejection region. So if our test statistic is bigger than this critical value, then we will reject the null hypothesis. If test statistic is not bigger than this or less than this value, then we fail to reject the null hypothesis. Now you can see we have calculated value of test statistic, and it is nothing but 49.6323, and this value is 5.991. So 49.63, that is always greater than 5.991. Therefore we are in rejection region, and therefore we reject the null hypothesis. So that also I have written systematically. We have to mention degrees of freedom equal to number of rows minus 1, number of columns minus 1, and it turns out to be 2. And using chi-square table, we find this critical value for alpha equal to 0.05 and 2 degrees of freedom, and it is 5.991. So I have sketched this rough sketch of chi-square density curve. This point is chi-square 0.05 with 2 degrees of freedom, and we find that this is nothing but 5.991 using chi-square table, and calculated value of test statistic is 49.6323, which is obviously greater than this chi-square critical value. Therefore we are in rejection region, and therefore we reject the null hypothesis. And null hypothesis is that the preference for pension plans and job classification are independent, but we are rejecting the null hypothesis. Therefore we can say that the preference for pension plans is not independent of job classification. So in this way we can apply chi-square test of independence to check whether given two categorical variables are independent or not. And for that, our null hypothesis is always that given two variables are independent, and using that null hypothesis we find out expected frequencies, and then we calculate value of test statistic using this formula, and after that we compare calculated value of test statistic with critical value of chi-square distribution at given level of significance and number of degrees of freedom. So this is second example on chi-square test of independence, and in lecture number 34 we have discussed about this test and one example also. If you have not seen lecture number 34, I suggest you to watch lecture number 34 first and then go for this lecture. Okay, fine. So I hope you like this lecture. Thanks for watching.